toy soldiers are sold in packets of 16. The soldiers are painted different colours, but it's known that 25% are red. Find the probability of a randomly chosen packet that more than 5 are painted red. If Josh buys 6 packets of soldiers, find the probability at most of the packet contains more than 5 red painted soldiers. Okay, let's deal with the first bit first of all. So let x be the random variable, the number of red painted soldiers in a packet of 16. So n will be 16 and the probability of success will be 0.25. We want the probability is x is more than 5, that's the probability that x is greater than or equal to 6. So if we go to our GeoGebra applet, and I've already set up 16 and 0.25, and less more than x more than 6 gives me this answer here. Okay, I get that by adding up all these probabilities. If I want to do that using the cumulative distribution function, I go to that one. Okay, and then I consider 5, and then I take that away from 1. Okay, the reason for that, if we go back to this one here, the PDF, is because the upper region here is got by doing 1 minus the lower region. Okay, so using the PDF probability density function, we get that. We would need to sum those probabilities, but normally these days you're given cumulative distribution function tables, so we would have to do look at this one here, which is 5, and then do 1 minus the probability that x is less than 5, which is 1 minus, taking that one at 0.8103, which is equal to 0.1897, and then to 3 significant figures that will be 0.190. However, we're going to use this one here in the next bit of the question. If Josh buys 6 packets of soldiers, find the probability at most 2 of the packets contain more than 5 red painted soldiers. So the probability that a packet contains 5 red shoulders, well, let's first let y be the random variable, the number of packets that contain more than 5 red painted soldiers out of 6 packets. Then y will be binomially distributed. There's 6 packets to consider, and the probability that a packet has more than 5 red painted soldiers is 0.1897 from part A. The probability of success of containing more than 5 red soldiers in a packet. So probability, we want at most 2. So we want the probability that y must be less than or equal to 2. Now we'd have to find that from the probability x is equal to 0 plus the probability x is equal to 1 plus the probability x is equal to 2. Now we've got some technology, but maybe in an A-level exam you don't have the technology, so you would have to do q to the 6 plus 6c1p to the 1 q to the 5 plus 6c2 p squared q to the 4. Q will be 1 minus p, which gives me 1 minus 0.1897, which gives me 0.8103. So putting those numbers in, we'd have to do 0.8103 to the power of 6, plus 6c1, 0.1897, times 0.8103 to the 5, plus 6c2, 0.1897 squared, times 0.8103 to the 4. Now if you bash that on your calculator, you're going to get 0.913365, and then round that off to 3 significant figures to get 0.913 as your final answer. Now if we go back to this and then change this here now to 6, and then put the probability of success for a packet, which is that, and we did less than 2, you see we'd end up with the same answer, this being the answer here. that adding, you'd have to sum these probabilities up here, you'd have to sum these up to get the answer, or if you wanted to use the CDF, then you get the answer straight away from here, 0.9134. So if we go along to the last page here, there's a screenshot of that. Okay, this being the answer, or summing these, probabilities. Will give me the answer. Alright, but we don't have that sort of software, we just have the table, so we'd have to do it the old-fashioned way, but we can use GeoGebra to actually check our answer. Okay, I hope you've understood this video, and I thank you very much for watching.